So the next thing I want to do is get into more detail about SD-WAN, Edge Network Intelligence, and Sassy as it relates, again, to IoT operational assurance for healthcare in particular. So with that, first I want to talk about SD-WAN or VMware SD-WAN. Not sure how familiar folks are with VMware SD-WAN, but sort of just to describe what the architecture looks like, it starts off with VMware SD-WAN edges, which are basically edge routers that sit in campuses, branches, or clinics, or even people's homes with the advent of remote healthcare and sort of COVID and all that, right? So that's one side of the architecture. The other side of the architecture is on the application side for applications that are hosted in the data center that devices are connecting to. You would deploy another VMware SD-WAN edge or hub device at the data center side of it. And for efficient on-ramp to the internet, we have a notion of the VMware SD-WAN gateway, which is offered as a service that can significantly optimize application performance as devices are accessing critical SaaS applications, like the one shown here as an example. And then, of course, for just generic internet, casual applications, there's just a direct connection to the internet. Now, the key differentiator of VMware SD-WAN is what we call dynamic multipath optimization. It's really to enable devices to connect to applications in the most efficient way, where the decisions are being made on a per packet basis to either steer application traffic in the right way across multiple WAN links, whatever they are, whether it's DSL, cable, LTE, or even MPLS for that matter. So there's the packet steering side of things for each application. And then there's also the forward error correction that is enabled by these systems as well to sort of help repair application performance and enhance application performance, even in some cases on a single link, like I'll talk about, right? So that's sort of the basic premise of SD-WAN from the performance side. And I'll also talk about sort of segmentation and on the security side of things as well. So the next thing that I wanted to talk about, again, sort of going back to the IoT operational assurance point, here's an example of a Zoom meeting performance being enhanced. But of course, we could think of this as a telehealth use case or a use case where a device is trying to send large image files or a device is trying to send video and so on. And basically, here's an example of how SD-WAN can help. This picture shows sort of, or the slide shows two graphs here. The top one is a client doing a Zoom call over a non-SD-WAN network. And the bottom graph shows a client doing a Zoom call over an SD-WAN network, both which have a single WAN link, but 20% simulated packet loss on that WAN link. And you can see here that in the bottom graph, the loss percentage is reduced significantly with SD-WAN that the application actually faces. It's 3% versus 17%. And the resolution of the actual video call that this client is having is 1280 by 720 versus 640 by 360, where obviously the application is going to react to network conditions and reduce resolution, reduce quality. But if SD-WAN is working in the background to sort of help out and make network conditions better, the application will respond better as well, as kind of shown here. So the next thing that I want to talk about with SD-WAN is segmentation. So we talked about performance and ensuring IoT devices have optimal application performance. The other part of this is segmentation and microsegmentation, wherein the SD-WAN network has segmentation built in, and as well as programmability. So everything is API driven. It's very easy by way of the VeloCloud or VMware Orchestrator in order to be able to program policies that automatically segment traffic and can do other things as well, like prioritize certain traffic over others and so on. And so that's sort of an important element of how we need to think about operational assurance from an end-to-end standpoint for all of these devices. The next thing that I want to talk about, or the next product that I want to talk about, is Edge Network Intelligence. And Edge Network Intelligence, formerly Nyansa and Voyance, is a platform that looks at every single end client device, whether it's a user device or, for this presentation, more specifically IoT devices, and looks at their user experience and device behavior across every step of them connecting to their applications. So when they connect to either a wireless or wired network, what conditions look like there. When they get authenticated with Radius, get an IP address, get DNS, get out to the wide area network, go through security services, and finally access their applications. All of this data that describes how clients are doing this is sent to the Edge Network Intelligence platform, or at least metadata that describes it. And the way this data is collected, basically to get insight into the wireless side, the Edge Network Intelligence talks to a wireless LAN controller. To get insight into network services, we talk to different network services, Radius servers and so on, SD-WAN systems and the like as well. In addition, the system also does deep packet inspection, or it doesn't do deep packet inspection, but a collector or an SD-WAN edge can do deep packet inspection on traffic, extract flow metadata, and send that flow metadata back to Edge Network Intelligence as well. So all of these data sources kind of combine to sort of give this idea about every single client device's experience and behavior. The final data source that it's probably worth describing a little bit also is directly from applications themselves. So I talked about Zoom on the last slide. Well, there's an API to get direct user behavior and performance data from Zoom itself. And that data, again, can be fed directly into the Edge Network Intelligence platform to sort of correlate application performance from that kind of an API directly down to what are the root causes of that poor application performance and so on, all again towards the end of operational assurance for IoT devices in healthcare networks. So with that sort of, I'll kind of just go through a couple of example use cases, again, tying back to sort of the operational life cycle of IoT devices from an IT standpoint. So the first thing is inventory. So this is just a screenshot from the product about the fact of how inventory sort of works, that we're now able to identify devices with specific names, like a McKesson AccuDose machine, as opposed to just a MAC address or an IP address, which obviously just gives us a lot more context when we talk about operational assurance, whether that's security or performance of these devices. Additionally, down here, you can see very detailed information into some different Philips devices in terms of serial number, software version, and so on. This is coming from the fact that some of these devices use protocols like DICOM, as an example, which embeds a lot of this information. But another aspect of this is also, in certain cases, we integrate very closely with certain manufacturers, GE being one example of them, where those systems from those manufacturers can also give us this kind of detailed information about inventory. So that's the first part of this, is identifying critical IoT devices. The next part of this is on a client-by-client basis, having the system automatically figure out how that client is experiencing the network and how that client is behaving in terms of what kind of destinations it normally talks to. So when we talk about how a client is behaving on the network or performing on the network, we think about connectivity. So can this device connect, for example, on a wireless network? Does it have the right signal to noise ratio? Has it gotten authenticated? Has it gotten an IP address and things like that? And we think about application performance as well, for applications like video or real-time applications like that, or even non-real-time applications, but just making sure that communication is efficient. On the behavioral side, which is sort of on the right over here, is the notion of, again, an infusion pump shouldn't be talking to random destination addresses. And so what is the baseline of normal behavior that this particular device is talking to? what exact sites is it talking to? Are any of them risky? Are any of them outliers or anomalous from the perspective of this particular device never talked to that destination before, and now all of a sudden it's talking to it? Or this particular infusion pump is behaving differently from all of the other infusion pumps at this exact same hospital with the same model. So what is happening there? So those are the two aspects of performance and behavior that is the next aspect of operational assurance. The next part of this is tying together different groups that have, a purview and care about these kind of use cases. And so in healthcare, one example of that kind of a group is the biomedical group that actually owns the devices, whether it's the bedside monitors or MRI machines or whatever have you. And while IT might want detailed information about signal to noise ratio or packet loss and jitter and things like that, biomed just wants sort of a quick view of just the devices they own. And from a performance or a security standpoint, whether the light is red or green, basically, right? Does this device have a problem, whether performance or security related? And do I need to, go down there and investigate it and do something there? And so having dashboards, having reports that sort of address these type of users is critical with any kind of solution that addresses this problem. Alerting and getting information with the right context is also key. So rather than sort of the old days of monitoring of, hey, switch interface 55 went down and there's an alert at 2 a.m. in the morning, it's far more valuable to have an alert like that same switch interface went down, but actually the IoT devices that were connected to that switch interface were your central stations in hospital number 5. Obviously, information like that can easily give you indication of, all right, do I need to wake up at 2 a.m. and solve this? Maybe in that case, the answer would be yes. Versus a switch interface went down, nobody was connected to it, or some device that's not very critical was on it, and it doesn't really matter. So that's sort of the idea of contextual information that comes with this as well. The next aspect is enabling IT to be proactive. So it's one thing of something going down and somebody complaining about it, calling in and saying that there's a problem. It's another thing about a system automatically learning patterns where devices are having problems over and over and over again, whether it's from, again, a security or a performance standpoint. And so that's the next part of this, which is that the system automatically surfaces client devices that are having problems over and over and over again, or at a specific time of day or whatever have you, and makes alerts or reports or makes recommendations as well on how IT can address these problems. And so this is another critical aspect of any kind of machine learning or AI platform, that the whole goal at the end of the day is to be able to take us from sort of more of a reactive mode of operation to actually be able to be proactive about this. The next aspect of this is, not just for a single client, but actually aggregating this data for lots of clients and being able to figure out anomalous behavior from an aggregated device standpoint, but also, alert on that, give the right contextual information. So in this particular case, 300 out of 720 clients, so 40% of devices at a particular time had poor Citrix virtual app performance, which would be a critical application. And the baseline is normally something like 7% or whatever it is. So it's a big deviation from the baseline. Now, can we get an alert? Can we get root cause for the problem, in context data, and all of that? And then eventually mitigate this problem, with something like an SD-WAN system or whatever it is automatically. So that's another important aspect of this as well. Finally, just a quick note about change verification, and more importantly, having objective data to be able to know what the baseline of a certain type of problem is, and filter to, for example, very specific devices, and to be able to know that if you've made a fix or a change or anything in your network, did that actually make things better? Or did that make it worse? Or did things stay the same? But the key thing being to have objective data. So there's a view in the product that actually baselines things, or baselines different performance metrics, baseline security metrics, and can sort of show in this way that after an annotation of some change, whether things actually got worse, better, how much did they get better by, and so on. And that's sort of a super critical and very, very useful aspect of the product in the platform. The last part of what I want to talk about is SASE. And this is a new service that we're introducing as VMware. And basically the idea here is to offer a unified set of security services that are offered as a service. So as client devices in branches, campuses, homes, clinics, typically we talk about even coffee shops, but you're probably not going to find too many healthcare IoT devices in a coffee shop, so probably not as relevant. But the key thing is wherever devices are, for them to be able to go through a unified and a centralized set of security services that also sort of are co-located with the VMware SD-WAN gateways to sort of make what we call a SASE POP. And so all of these devices can go through security services like secure access, like cloud web security, like next generation firewall, and so on and so forth, before going out to their critical applications. And that being sort of an integral part on the security side to sort of complete this operational assurance story as well. Then the last slide is just a double click on what kind of services those are. And you can kind of see here sort of, on the secure access side, what kind of security services are present. On the cloud web security side, things like URL filtering, anti-malware, antivirus, all of that stuff, and next generation cloud firewall, and so on. But hopefully with that, I've kind of given folks sort of a unified picture of how a set of VMware products can sort of come together and address the IoT operational use case. And in the second presentation, double clicked on that and given some more details about exactly how our products work and how they address this problem. But with that, let me throw it back to you guys in terms of agree, disagree. Do you guys, where do you guys see there being holes in the solution or anything like that? Questions, comments, etc.
Yeah, hi Anand. This is Greg Stewart again. The question I had was around like the biomed dashboard and a lot of the metrics that are being gathered. So I love it. It seems very granular from an IT administrator perspective. I think that's great to have all that data on a dashboard. But for me, it seems a lot like vRealize operations kind of on steroids. And I'm wondering, like if you have VROPs already in place and you bring this in, is there much of a learning curve involved in that? Is there a need to have both of those utilities within your data center? Or?
Yeah, so great question, Greg. And this comes up often, especially us being VMware and data center kind of being our sort of traditional bread and butter. And so we kind of split out products that are focused in the data center and with for use cases that are sort of primarily on the data center side versus use cases and products that are primarily focused on the network edge. So in the, when you think about IoT devices, there's kind of two aspects of it. There's the notion of IoT devices connecting to the network at the edge, where things like wireless connectivity is important, right? Knowing that the client got an IP address with its DHCP service or server is important, right? Knowing that it got authenticated, that it even got out to the application is important. So from this perspective, the edge perspective, the data center itself or the cloud or the hypervisor layer or whatever it is all just a complete black box. Because if you think about the folks that are at the edge, right, or managing devices at the edge, whether that's corporate IT, the wireless guys, the LAN guys, the service desk folks, or whoever it is, data center is kind of probably a bit of Greek or not necessarily in their purview. On the other hand, when you have products like VROps, or we have another product called VRNI as well, vRealize Network Insight, you talk about applications more from the perspective of, hey, we have these web servers talking to these application servers, talking to these database servers, using these services. What's the performance between those different systems? And we talk about a lot more from the application developer or the application operations or the data center network operations side of things. And so in that way, products like VROps or VRNI are complementary to products like Edge Network Intelligence. And in that they sort of have very different focus areas, but with the two of them, you kind of get an end-to-end picture. But typically they're consumed by different customers and different personas within IT. Hopefully that answered your question.
Yeah, no, it's perfect. Thank you.
I have a question which might have been answered in the first part, but it's more around IoT devices and security. So we know that historically, all of these devices have been segmented. They've been running on their own network because of the security risks and because the fact that those devices were not very secured. So I do not know what is the state of the industry these days, especially in medical IoT, but it's kind of still something which is quite stressful. So, and I don't know if that is a feature of your product. I don't think that might be the core feature of what you guys do with VMware SD-WAN, but do you have a kind of way of informing the admin about whether a device is secure, whether it's not secured, if there is any kind of protocol which needs to be enabled or disabled?
Yeah, so a key use case around this is that behavioral analysis of what are these devices talking to. So that's one side of it, and making sure that a device doesn't all of a sudden start talking to a new destination that it never talked to before, or that a device isn't talking to a high-risk destination, and being able to sort of inform other security systems of that kind of behavioral anomaly, right? The other side of it is, through things like Sassy and other kinds of security services, making sure that IoT devices, as they connect to, whether it's the internet or applications, are going through a specific set of security services that have a centralized set of policies that govern all IT networks in the enterprise. And this comes back to, I don't think people want to operate OT networks that are completely segmented, because it's just a pain to sort of operate multiple completely independent networks and proprietary networks and so on. People want to put stuff on just one network fabric, like the overall IT network. But in order to do so, we have to be able to make sure that performance and security are assured in those kind of networks. So the key thing is having the right set of systems to do, as I said, behavioral analysis and anomaly detection with machine learning in sort of a world where we don't have signatures for these threats are already learned. And so we have to learn sort of anomalies and detect things that way. But also just for the traditional set of security services as well, signatures, detection, anti-malware, antivirus, URL filtering, all of that good stuff as well. And so that's where sort of, the combination of things like Edge Network Intelligence as well as Sassy kind of come together on that front.
It's always been an issue in networking to balance usability and security. And being in the healthcare field, it's probably security probably wins that balance. But yeah. How do you help an organization deploy this in a brownfield environment and knowing that it's not going to break usability or affect their operations? Is there a learning mode before an enforcement mode? How are you selling this to your customers?
Yeah, absolutely. It's a great point. So first and foremost, in terms of the way the solution comes in, it's geared to, like, Edge Network Intelligence in particular is geared to brownfield deployments. So it's multi-vendor, we talk to different, vendors, wireless, different vendors, switches, different vendors, radius, and things like that. And obviously packet data is completely vendor agnostic as well. So it's vendor agnostic, comes in brownfield. As you said, Bruno, it learns for a while. It learns baselines, learns inventory, learns everything that's going on. And basically security would start to integrate taking action with the rest of their system, either by way of a network access control integration with something like Cisco ICE and PX Grid, or by way of an integration with SD-WAN or a SIM or a SOAR by way of something like syslog as well, sort of feeding data into that SIM or SOAR and having the SIM and SOAR sort of take those actions. So that's one thing I definitely want to call out. Similarly, even SD-WAN, the way we've sort of deployed it or that we've developed it is you can sort of do a phased deployment of SD-WAN where it's not like a complete rip and replacement of your existing routing framework and so on. You can sort of add it, with some of your traffic, or just even sort of as another router to sort of just see the benefits from an application performance standpoint, and then sort of go from there. And so that's kind of what I would say in terms of brownfield deployments, making sure that things can still work as they worked and it's not too much disruption. But going back to the first part of your question, which is kind of more of a general usability versus security, I think that trade-off is always going to be there. One thing that I would call out is because Edge Network Intelligence has the notion of performance assurance as well as security assurance, whenever that balance is kind of breached, an example being, all right, I'm going to do, SSL decryption and URL filtering at all my firewalls, for example. But now all of a sudden, application performance is really, really slow. Well, that's something that Edge Network Intelligence will catch. It'll say that performance has actually gone bad after you made this change to add all these security things, gates in the middle. And then the enterprise just has to ask itself, what's the balance? What do I want to do here? And then figure that out. But that's why sort of performance and security sort of makes up operational assurance as opposed to just one or the other.
Anand, Tom Hollingsworth here, networking nerd on Twitter. I've got a question kind of regarding the idea of taking people out of the loop. I know that VMware's done a lot of research and a lot of development around the idea of zero trust networking, and obviously the intelligence that they're getting from the former Nyansa platform is going to give them a lot of better metrics on how to tune those networks and how to look for anomalies. But I wonder if the customers that you're talking to are giving you feedback regarding integrating those two things tightly together, where the reporting data that they get from Voyance and its integrations into the Zero Trust platform is good enough that they feel comfortable saying, okay, if this device deviates from spec, lock it down and fire a report so that I can stay in compliance, or if they're still taking that wait and see approach of tell me that it's doing something that it's not supposed to and let me push the big red button to turn it off. Because I know that when you're in a highly regulated environment like healthcare, those time decisions can cause a massive amount of paperwork when the auditors come in and start asking questions about, why was the glucose monitor suddenly accessing the patient data on this restricted wing or something?
That's a really good point, Tom. But the other side of it is, why did you disconnect this MRI while it was scanning a patient or whatever it is, right? Or disconnect this infusion pump while it was dispensing drugs to somebody. So healthcare is just one of these things that you want to be super careful with the type of actions you take. So I would say probably in the two regimes that you talked about, we're still probably in the mode of tell us exactly what's going on here and let us push the big red button and disconnect this MRI or disconnect this infusion pump or whatever have you, rather than the fully self-healing, self-optimizing network. But obviously the vision of pretty much every network analytics platform and networking platform for that matter is to get to sort of some kind of autonomous network where basically the system can take remedial actions or healing actions on its own and lets IT know exactly what action it took, why it took it, what happened after it took the action, so that then IT can sort of fine tune it after the fact, but it's kind of all automated. And so it sort of reduces the burden on IT to sort of manually intervene. But what I would say definitely right now I would say we're probably more on the first side. You know, we don't want to kill anyone, Tom. Come on.
Yeah, let's not do that. But I think you're right from that perspective of highly regulated industries are probably going to require a lot of manual intervention just for reporting chain purposes of we'd rather be safe than very, very sorry.
Absolutely. Absolutely.
One question for myself as well. Do you have a way to somehow report on some, abnormal configurations or things which do not make sense? For example, let's say somebody has been defining some QoS or reserving some bandwidth for really important devices like MRIs, for example, and suddenly somebody switches it off. And, is there a way to kind of detect that, MRI and other equipment should get the highest priority? Somebody turns it off and suddenly, let's say Netflix traffic, as you say, it goes up in the hospital.
No, exactly. And that's a super important use case actually in the platform. So the idea is learn baselines for every device category for every type of metric. So in this particular case, we would be looking at a baseline for the MRI machine's application performance as an example. And all of a sudden after this change you mentioned, that baseline would significantly deviate. It would get a lot worse. And that would generate sort of an alert to say, wait a minute, something has happened with these MRI devices where their application performance is a lot worse than what it used to be. What happened in between? And in sort of a baseline view, you can explicitly see that there's an annotation for a specific configuration change where with certain types of systems, we automatically detect that configuration change by looking at diffs between the configuration. With other systems, you might have to manually annotate it and say, I made this change at this point. But after that, you would explicitly get to see that, hey, before this annotation, the baseline was this. After this annotation, this baseline, went haywire. So that change is very likely the cause of this particular problem. So, let's prioritize MRIs over that Facebook traffic. Would be the solution. Awesome. I think that covers it. Thank you very much, to you guys for taking part in the discussion and hearing me blather on about this topic. And thanks for everyone out there watching and listening to this. If you want more information, you can go to velocloud.com or VMware and look for either Edge Network Intelligence or VMware SD-WAN to get more information.